Hey everyone, and welcome back to our channel. Today we are talking about a problem that a lot of companies are facing right now. We've all seen the incredible power of large language models and GenAI models in general across modalities like text, audio, image, and many others. And that's led to a wave of innovation. But there's a serious problem which is not very well understood. Prototyping with generative AI is relatively easy, but when you move away from that simple prototype to a full-blown production application, things can get messy real fast. And this mess is what we call the productionizing nightmare. This applies regardless of whether you're using open source or proprietary models. What productionizing essentially means is that it's not just about a cool demo or a quick experiment. It's about building something that is reliable, secure, and scalable enough to serve thousands of customers. Now, to truly understand the stakes, let's look at a few real-life scenarios which can occur if generative AI is deployed prematurely. Imagine a large financial services firm. Their legal team is using an AI application to summarize complex legal contracts, a process that handles highly sensitive client data. They're using a third-party LLM for this task. While the vendor guarantees data privacy, the Chief Information Security Officer and the compliance teams raise a major red flag. There is no centralized, verifiable record of every prompt and the response. Now, if they face a regulatory audit, they have no way to prove exactly what data was sent to the model or what the model's output was. The company thus lacks the auditable chain of custody required for complete governance and compliance. The project becomes effectively dead on arrival until a solution can provide that forensic report. Think about it. What if you had to tell your CEO that a mission-critical AI project was on hold because your company could face a multi-million-dollar fine for non-compliance? Not ideal, is it? Now imagine a massive e-commerce company with dozens of business units, all using AI models for different tasks, from customer service chatbots to product description generation. What is happening is your budget is spiraling out of control with all of these units using generative AI. Each business unit is managing its own API keys and contracts with different vendors. Now, there is no centralized way to monitor token usage or set granular spending caps. Worse, the teams are getting logged into specific vendors. What happens with this is when a more cost-effective alternative becomes available or a vendor raises prices, the engineering effort required to switch models would be massive, essentially making it impossible. The company is thus losing its ability to negotiate better deals and optimize costs at scale because there is no observability, and this is directly impacting the bottom line. Imagine trying to explain to CFO that your company's AI spend is growing 30% month on month, and you have no way to prove which teams are responsible for it or how to control that. Finally, let's look at a major automotive manufacturer that relies on a generative AI powered in-vehicle assistant that powers navigation, conversational search, and real-time infotainment. This system uses one specific LLM as its central intelligence, which has been obtained after a lot of fine-tuning. What is happening is at 3 a.m., that single LLM provider sometimes experiences a system-wide outage. The in-vehicle assistant, which has a direct dependency on that one provider, becomes unresponsive. Customers can no longer use voice commands for navigation, entertainment, or even simple queries like find the nearest charging station for me. This is the core functionality of that key customer-facing feature, and it grinds to a halt. There are no automatic fallbacks to a secondary LLM and no prearranged plan for business continuity of that. The company's brand reputation and customer satisfaction are at risk due to a single point of failure in its GenAI stack. Think about it. How would you explain to your company's board that you have no disaster recovery plan for your most critical AI systems? Now, all of these three scenarios are very, very real, practical scenarios that can happen at companies looking to productionize GenAI applications, and they're all facing one particular set of pain points. What are these pain points? Let's dive into these systematically one by one. Now, if you think about it, what's linking these all business problems together? The answer lies in the day-to-day technical complexities facing your generative AI developers. I will be highlighting 6 distinct issues here. like integration maze, inconsistency and versioning, scalability and reliability, lack of governance, open source integration, and the observability black hole. But there are quite a few more. Now, the most fundamental problem a developer faces is integration. Say your team wants to compare different models, either GPT-4 versus Claude 3.7 for cost mainly and performance, or they want to use an experiment with the same model from different providers. Think about DeepSeek from its official API versus DeepSeek from the Grok API. And this is mainly for latency comparisons. Or a third scenario would be they just want to experiment with different models across different providers for improving the performance. They have to spend countless hours writing custom code for each model with its own API and its own SDK. Now what happens is it makes it difficult to switch models and it makes the system fragile and a pain to maintain. If one model goes down or you want to switch to a cheaper one, you have to manually change code in every single application. That's a massive refactor. Now let's say a developer has solved this integration problem. What they now face is the issue of managing prompts and getting consistent results across different models. Your prompts are often the most valuable part of your AI application. But without a central system, prompts are just hard-coded in different places of your application. You cannot version them, you cannot A/B test them, or ensure everyone is using the latest, most effective version out there. The same prompt can also provide widely different results depending on the model you're using, and this leads to unpredictable responses. So this is the issue of inconsistency and versioning that also crops up. Now let's say a team has a working prototype in place after going through all of these issues and handling them. The next concern is about making it robust for real world traffic, which is where the scalability and reliability aspects come in. As your user base grows, you need to be able to handle a high volume of requests. Your application might be a real-time chatbot or an AI-powered assistant, where predictable response times and low latency is very crucial. But what happens is you are at the sole mercy of your model provider. Think about what would happen during a sudden traffic spike. You would be hit with rate limits by the model provider. Or there could also be service outages when an entire service like OpenAI or Anthropic could go down for maintenance. And you can see this has happened over the last few months, although this is very infrequent, but it does happen. Now what happens here? Your whole application goes down for a while. Now let's move to one more large problem, which is the lack of governance. And because this is a high-level large problem, I will break it down into three distinct issues. As soon as you scale beyond a certain project or a certain team, you start losing control over a lot of things. You start losing control over security, access, and costs. Now with security, there's no way to consistently apply a security policy across all of your models. Also, every model requires its own API key, so you have to manage these keys, and ensuring sensitive data is not being leaked to third parties becomes a huge pain. Also think about staying compliant with regulations like GDPR or HIPAA. That becomes a huge risk. With access, you cannot set rate limits for specific users or enforce a standard like role-based access control to ensure that only authorized teams can access certain models. That becomes difficult. On top of that, you cannot enforce budget constraints by setting cost-based or token-based quotas. So effectively, every team becomes a silo in their operations, and the risk of data leakage, accidental overspending, or unauthorized access skyrockets. It's a massive security gap just waiting to happen around the corner. Now let's more specifically consider open source integration as a problem. Leveraging hosted proprietary models through APIs becomes more streamlined because you're just hitting APIs than hosting your own open source model, right? But what happens is a lot of companies want to use self-hosted models because of cost or privacy concerns. Now, integrating these open source self-hosted models into an existing GenAI stack is a huge pain because you have to handle all the infrastructure yourself. GPU scheduling, auto scaling, and also the deployment. and you lose the consistency of a unified API as well. This makes it almost impossible to manage both commercial and open source models side by side. So you can see that open source integration is also a huge problem for companies looking to use open source models. Finally, there's a huge observability black hole that is created and generated via all of these problems coming together. When a user is reporting an issue, you cannot easily debug it because you do not have any centralized logs to inspect the full request and response history. You have no way to filter metrics by team or the environment, and you have no way to identify why a request failed. You're left flying blind, making it nearly impossible to troubleshoot as well as optimize your applications. So we have talked about the problems so far, the chaos, the security risks, the unpredictable costs. But what's the solution to all of this? How do we build a robust, scalable generative AI infrastructure without the productionizing nightmare that we talked about? The answer lies in something very elegant that is called an AI gateway. Now, an AI gateway is a specialized middle layer that sits between your applications and the various AI models that you're using. It acts as a single intelligent control point for all of your AI traffic, managing everything like security, observability, and governance. And thus it makes it very simple to scale generative AI applications reliably. Architecturally, the AI gateway is designed to solve the pain points we discussed by being a centralized middle layer. It simplifies your infrastructure by decoupling your applications from your external or internal AI services. And what I mean by these AI services is this can be self-hosted or proprietary LLMs, or this can also be MCP servers, where MCP stands for Model Context Protocol. This means your developers code to a single API endpoint, and this gateway endpoint handles the complexity behind the scenes. Now, this centralized design is how you gain control over everything, from managing costs to security to ensuring reliability and performance. Now, let's understand it visually. What's happening here, if you see the bottom right diagram, is that the AI gateway receives an API call from an application or from multiple applications, and then it processes those requests before sending it to the correct LLM. Now, this process can involve a lot of things. Firstly, routing to appropriate model that can be processed and done by the AI gateway, or translating the request from the application's format into a specific API format required by the target LLM, or adding necessary API keys or tokens required by that specific target LLM for authentication and authorization. So the gateway also does that. Or finally, caching can be done to check if a similar request has been made before by any application, and the AI gateway then ensures that a cached response is returned to save time and money without needing to call the LLMs again. In essence, what's happening is the AI gateway is transforming a generic API call to a model-specific API request, acting as a bridge which is sitting in the center between your applications and your LLM APIs as well as MCP servers. So in general, any AI service, internal or external. Now let's get a little bit more technical and look at the real architectural definition. AI gateway is a specialized middleware component and egress proxy that serves as a centralized control plane, providing a unified observable interface for your entire GenAI stack. Now, let's break down what each of these highlighted terms actually mean. First, middleware. The AI gateway sits between your applications and LLM APIs, abstracting away provider-specific logic. It operates at the application level, offering a clean, consistent integration service regardless of which model or provider you're using. Now, because it is in this middle prime location, it is able to act as an egress proxy. Specifically, this means that the AI gateway manages outbound traffic, that is routing requests from your internal applications to external providers like OpenAI or Anthropic. Now, egress proxy operates at the data plane, technically speaking, at the network level. Now, we have discussed that it acts as a middleware and also as an egress proxy. Now, combining these two concepts enable it to become a centralized control plane, which is the core concept of the AI gateway. By consolidating all application level traffic from your organization, you get a network level capability. All of your AI requests are funneled through this one single hub. This is the single point where you can gain complete control over your entire generative AI stack. Effectively, simply, it means that it is acting like a traffic controller, directing all the traffic. And finally, if you think about what benefit this yields, is that it becomes a unified observable interface for generative AI at scale. You can easily enforce policies, monitor usage, and route requests intelligently. It is able to provide a single standardized API for all your developers and applications to use, abstracting away the underlying complexity of each individual LLM. Pretty powerful. Now, you might be thinking, isn't this just an API gateway? That's a great question. Now, a traditional API gateway functions as an ingress proxy. Its primary job is to be the single secure front door for all inbound traffic. That is, it handles all the requests coming into your system and protects your internal microservices by managing authentication, load balancing, and rate limiting. It is designed to secure your system from the outside world. An AI gateway, on the other hand, is a completely different kind of system. It is an egress proxy, which means that it manages all the outbound traffic coming from your internal system. Its job is to handle the unique and complex challenges of consuming AI models, which a standard API gateway is not designed for. Things like token-based rate limiting for cost management or semantic caching to remove redundant calls to expensive models, or model orchestration like intelligently routing requests to different LLMs. Now, that said, inherently, these are not fundamentally different. How? Because both can be configured to proxy either direction. The distinction between the two, API gateway and AI gateway, is not a hard technical limitation, so to speak, but it is a difference in the purpose-built design, feature sets that they are armed with, and the usage patterns. But this is the easiest way to understand what is the key difference between an API gateway and the AI gateway. Now that we know what an AI gateway is and how it's designed, let's dive into the core features that directly solve the productionizing nightmare we discussed in the beginning. Let's begin with the foundation, that is access and control. The first feature is the AI gateway offers unified access. Instead of juggling multiple APIs and multiple keys, teams use a single API interface to connect with OpenAI, Anthropic, Cohere, or even internal models. This drastically reduces complexity. Then there's authentication and authorization. Keys are centrally managed. What happens is that developers receive scoped API keys, and root credentials, on the other hand, stay secure via services like AWS SSM or Azure Vault. Add to that role-based access control, or RBAC, which enforces fine-grained permissions across users, teams, or model types, ensuring your GenAI infrastructure aligns with your enterprise security needs. Now, once access is in place, the next step is to intelligently manage the traffic that's coming up. Here, routing and fallbacks is one key feature that allows you to direct traffic based on performance, cost, or provider availability. If one model is slow or down, the gateway can automatically retry with another, improving resiliency without requiring manual intervention. Then there is rate limiting and load balancing. You can configure quotas at the user or the team level and balance traffic across providers to maintain throughput and stability, especially important in very heavy load conditions. And then with caching, the gateway can store responses to repeated prompts, saving on tokens and reducing latency for common queries. So this is all about intelligently managing the traffic and making it more efficient. Now, once traffic is flowing, you need visibility. And this is where AI gateways really shine. With performance monitoring, you can track latency, token throughput, and error rates per model or model endpoint. This helps you identify bottlenecks and maintain SLAs. Then there is usage analytics. You get detailed logs and dashboards that show who used what model, when did they use it, and how that model was used, enabling cross-team transparency and better collaboration. And critically, cost management at the end, right? Since token usage is tracked per user, team, or model endpoint, you can attribute costs precisely and stay ahead of budget overruns, which is very, very critical when you're using LLMs, because a lot of these LLMs are really expensive. Now, AI gateways are not just built around control. They're also designed for extensibility, and that is a key feature. Through API integrations, you can plug in tools like evaluation pipelines, prompt moderation layers, or even vector databases, enriching your LLM workflows without additional glue code in your applications. And with custom model support, you can bring your own fine-tuned or proprietary models into the gateway, giving them the same interface, the same standard interface and policy enforcement like hosted models as GPT-4 or Claude. Now, this makes the gateway a very composable layer that fits into your existing AI/ML ecosystem, whether you're in R&D or managing production scale deployments. So it's very, very flexible, so to speak. Now, to recap all that we have talked about, AI Gateway becomes the one gateway to rule and govern the LLM calls. It centralizes access and enforces enterprise-grade security. It routes and manages traffic intelligently like fallbacks and caching. It offers full observability and cost tracking across teams. And it integrates cleanly with your tools, workflows, and custom models also. All together, it is providing a structured, scalable foundation for enterprise generative AI. Now, with all of these features in mind, let's revisit the three problematic scenarios we discussed in the very beginning and see exactly how the AI gateway solves for them. Now, let's see these real risks. The first one, if you remember, was compliance and audit. Without audit logs, you were flying blind in front of regulators. Now, with the AI gateway, every prompt and response is logged, secured, and attributable, making compliance automatic, not optional. Second was the budget chaos and the vendor lock-in. When spend is invisible, it is unmanageable. Now, the gateway gives you fine-grained cost tracking and enforces usage controls while letting you route across the vendors without any lock-in. And third was the operational risk. A single LLM dependency was a single point of failure. The gateway instead introduces failovers, load balancing, and caching, keeping your AI applications resilient and always on, always online. In short, every risk scenario we opened with now has a very, very clear, scalable, efficient solution, that is the AI gateway. And that's the big picture. Not just what an AI gateway does, but why does it even matter? Think about it. You will never deploy software without version control or observability. Why deploy generative AI without an AI gateway? Now, the key takeaway I want to leave you with is that an AI gateway is not just infrastructure. It is how you make generative AI safe, scalable, and enterprise ready. It closes the gaps in compliance, spend, and reliability, and creates a foundation layer where generative AI can grow with confidence in your organization and drive real value, not just expected value. Thank you for watching.